So, students, in the last class we discussed about the resistivity, right? So today we are going to discuss resistors. So what are resistors, right? So resistors are the devices which controls the flow of current in an electric circuit. So there is a difference in resistor and to that of the resistance, right? So resistance is the internal property of the material. So if we consider any one conductor, so each and every conductor follows the resistance. That is, it is the intrinsic property of the conductors and also the insulators. So in conductors the resistance is less, and in insulator the resistance is more, right? So this one is the intrinsic property of the material. So what are resistors? So resistors are the devices, right? So these devices which controls the flow of current in the electric circuit, right? So what are resistors? Resistors are the devices which control or reduce the flow of current in the electric circuit, right? We have so many number of the resistors. So in our syllabus we have just two types of the resistors. One is wire wound resistor or wire bound resistor, and the second one is carbon resistor. So our main aim is to discuss only on the carbon resistor. So what are the difference between the wire wound resistor, that is wire wound or wire bound resistor, and to that of the carbon resistor? So these are made up of the alloys, right? So alloy material is used to wind the wires in spherical shape or in the sinusoidal shape, right? So these are the resistors which are made up of the alloys. So example for those alloys are manganese, and temperature is directly related with the resistivity. So as the temperature varies, the resistivity of the material changes. But in alloy, as the temperature increases, the resistivity is little vary, right? So not that of more variation with compared metals. So these resistivity are very less vary with the temperature. Hence, here we are using the alloys, and these wire bond resistors as fixed values, right? So that is from few ohms to few hundred ohms, right? So these wire bond resistors have only the fixed value. If they are ready, maintain the values of some values only in prepared for only the 50 ohms, we are getting only for the 50 ohms, right? So this is about the wire wound resistance. So these are made up of the alloys, and why? Because these alloys are used in wire bound resistors, means these are very negligible vary. The resistivity are very negligible vary with the temperature, right? So and the demerit of the wire bound resistor is it has only the fixed value of resistance, right? That is from few ohms to few hundred ohms. That is from 1 ohm to some 500 ohm or some 900 ohm. So the maximum limit is up to some 900 ohms. So this is about the wire wound resistor, right? So our main aim is to discuss the carbon resistor. So what are carbon resistors? These are the materials which are prepared by the carbon. That is, these are made up of carbon, right? So these are very small in size. That is, these are compact in size, right? And so that's why we are using the carbon resistor. Less expensive means, so these are available in just only for 50 paise or for 1 rupees. We are getting these carbon resistors, right? So widely these are used in laboratories and daily using electric circuits, right? So this one is the advantages. So these are very compact in sizes and these are very less expensive. That means that is in our labs also we are going to use, and also in daily using electrical circuits, right? So this is the carbon resistor, right? So here, as these carbon resistors are very compact in size, the values of the resistor is used, that means determined by using the color code. So why we are using the color code means these resistors are very small in size, so we are varying the resistance, right? So here we have only the fixed value of the resistor in the resistance in the wire bond resistor. So here in carbon resistor we can get either 1 ohm, or we get some 50 ohm, or we get some 60 ohm. So we are getting the variable, right? So we are going to discuss on the color code, right? So very important for 1 marks, color code of the resistor. So in competitive exam also they ask the color code of the resistors. Right? So these resistors, so carbon resistors, so these resistors are in cylindrical shape, right? So these are very small in size, right? So these resistors have the coaxial rings or coaxial bands. So each resistor having 4 coaxial rings or 4 coaxial bands. We can call these as bands or rings. So each ring we have the different colors, right? The coaxial rings. So this is the first ring, second, third, and fourth. So each rings or bands. So each rings or bands will give the different significant figures, right? So if we take on first column, that is color, and second one is the digit or number, and third one is multiplier, and the last one is tolerance, right? So starts with the colors: black, brown, red, orange. So these are all in the same order: yellow, violet, gray, and white, right? 2, 3, 4, 5, 6, 7, 8, 9 into this silver, gold, right? So two more colors, right? So the digit or the number starts from 0. For black it is 0, right? So for brown it is 1, for red 2, orange 3, yellow 4, green 5, blue 6, violet 7, gray 8, and white it is 9. So no numbers for the silver and gold, right? So next, multiply. That means the number of zeros which are going to multiply. So that is 10 to the here we are going to write in terms of 10 powers, right? So here 10 to the power of 0. That means its value is 1. So next is 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, 10 to the power of 4, 5, 10 to the power of 6, 10 to the power of 7, 10 to the power of 8, and 10 to the power of 9. So there is no multiplier for these two, silver and gold. And the last column is tolerance. So this is only for gold and silver. That is 5 and 10. Well, here one more, no color. If there is no color means that is the value is 20, right? So by using this, we are going to find the resistance of the resistor, right? So ನಮಗೆ ಯಾವುದೋ ಒಂದು resistor ಕೊಟ್ಟಿರ್ತಾರೆ, that resistor having the different color bands. So ಈ ಪ್ರತಿಯೊಂದು ring ಕೂಡ ಏನಿರುತ್ತೆ ನಮಗೆ different colors. So by using these colors, we are finding the value of the resistance of the resistor. So either it may be 500 ohm, 560, 900 or 960. So that all depends on these colors, right? So how means the first two rings, so the first ring and the second ring give the significant digit of the resistance of the first two digit, right? So for example, if we have the resistance R is equals to some 640 ohm. So this is taken as one example, right? So 640 ohm. So here 6 is the first digit and 4 is the second digit, right? So these two digits are representing by the first two rings of the resistor, right? So the first ring and second ring give the two significant figures of the first two digits of the resistance, right? So here 6, again by checking the digit here. So which is the 6? So 6 is for blue, right? So here we can write blue. So again 4, the second ring also be taken from the same digit, right? So that is 4 means yellow, right? So on the third digit represents what? The third ring, right? So this third ring is taken from the multiplier, right? So the first two digits of the or first two bands are always taken from the this digit, that is first and second ring, right? So the first ring and the second ring we taken from the digit or the number, right? So on the next third ring is taken from the multiplier, right? So in the third ring we have 0. That means we can write this 64 into 10. So 10 means its power is 1. So 10 to the power of 1 is 10. 10 into 64 we get the 640. So we can check 10 to the power of 1 is brown, right? So this is the color combination of the resistor, right? So in examination, if they given the resistance means we need to find the colors of the resistor, right? So if they given the colors, that means green, orange, blue, then silver. If they given the colors means we need to find the resistance of the resistor, right? So again by checking the same, right? So for first green means the first digit is 5. Next orange, so orange the digit is 3, that is 53, right? So next blue, that is 6, that means into 10 to the power of 6. So next silver, so silver is gives what? The tolerance, that means it is always plus or minus 5%. So this gives what? The resistance of the color code of the resistor, right? So on the last we need to write the symbol of the unit of the resistance, right? So tolerance means 5% tolerance means that means 5% variation in the given value, right? So either it may be 5% more or 5% less. So this gives what? The tolerance. So namage kottiro value alli for example 640 plus or minus 5% means the given resistance may vary 5% for the given value, right? So 5% na check madodre namge idralli, that is 5 divided by 100. So we get 0.05, 5 divided by 64 into 100, right? 5 divided by 64 into 100, right? So So here we get so if we take on this one as confident 10, some 10, that means we get 650, that is plus 650, or it may be minus 630. So this much is varying, that means 5%, right? So 5% of the given value means either it may be 5% increasing or 5% decreasing. So that gives what? The tolerance. So that one we call as the tolerance, right? So this is the color coding of the resistor, right? So ಇದು order ನಮಗೆ ಸೇಮ್ ಇರಬೇಕು, ಇದೇ order ಅಲ್ಲಿ ಇರಬೇಕು. If we change the colors in between means the value also the changes, then the answer will be wrong, right? So ಇದನ್ನ ನೆನಪಿಟ್ಕೋಬೇಕು ಅಂದ್ರೆ BB Roy, that means black, brown, red, orange, yellow, right? So next gray or goes Bombay via gateway, right? So this one is the statement. So in the first letters we need to remember. So black, brown, red, orange, yellow. So here G is green, B is blue, V is for violet, and G is for gray. And they given some 33,000 ohms. So the first two digits we are taken in the number, and this 3 digit we can write, that is 10 to the power of 3, right? So 10 to the power of 3 is again here. So the answer will be orange, orange, and again orange, right? So if they given some plus or minus 10% means orange, 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 and the last is gold, right? So this is the color coding of the resistor, right? So next, temperature dependence of resistivity. So resistivity is denoted by the symbol rho. So in the last class we also derived the relation for the rho, right? The resistivity rho. So temperature depends. Already I mentioned, as the temperature varies, the resistance of the material also varies, right? So we have the relation resistivity at any temperature T, that is equals to resistivity at the reference temperature to the of 1 plus alpha times of T minus T naught, right? So where rho T is the resistivity of the material at temperature T. So ಇದನ್ನ ನಾವು find out ಮಾಡಬೇಕಾಗಿರೋದು, right? So if we have any one conductor, insulator or semiconductor, so ಯಾವುದಾದರೂ ಒಂದು conductor, insulator or semiconductor ಇದು ಅಂದ್ರೆ, so ಇದ್ರದ್ದು resistivity find out ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ that one is the resistivity at any temperature T. So normal temperature we have 28 degree Celsius, right? So this degree we taken as the reference temperature T naught. So at that degree Celsius we have the resistivity initially conductor. So that one we taken as rho naught, that is resistivity of the material at reference temperature, that is T naught. Either it may be 28 degrees Celsius or 30 degrees Celsius or 32 degrees Celsius. So now ಯಾವ ರೆಫರೆನ್ಸ್ ಅಲ್ಲಿ ತಗೊಂಡಿರ್ತೀವೋ ಆ ರೆಸಿಸ್ಟಿವಿಟಿ ನ ಏನು ತಗೊಳ್ತಾ ಇದೀವಿ, rho naught, right? So next and the last is alpha, that is temperature coefficient of resistivity. So alpha another one constant, right? So that constant we naming as temperature coefficient of resistivity. For metals alpha is positive. So metals ಗೆ ನಾವು alpha value ನ positive ತಗೊಂಡ್ರೆ. So this one is the relation. So ಇದರಲ್ಲಿ ನಮಗೆ ಜಾಸ್ತಿ explanation ಅಂತ ಏನು ಇಲ್ಲ, right? Just we have the relation. So ನಮ್ಗೆ initially this temperature will taken as T naught, that is the reference temperature. So at this reference temperature initially it has some resistivity, some 0.00068 ohm meter, right? So this gives what? Resistivity of the material at this temperature. Now if we increase the temperature to this material, right? So that means increase in temperature, that means we are going to find the resistivity of the material at some 50 degree Celsius, right? That means we are going to increase the temperature. So as we increase the temperature, the resistivity of the material also the changes, right? So adana find out ಮಾಡ್ಕೊಳ್ಳೋದಕ್ಕೆ ನಮಗೆ ಇರೋ ಫಾರ್ಮುಲಾ ಯಾವುದು? Rho naught 1 plus alpha into T minus T naught, right? So ಇದ್ರ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅಂತ ಏನು ಇರಲ್ಲ, just for the reference purpose they mentioned, right? So on the main important, the dependence of the temperature with the resistivity. So we know the relation rho is equals to m divided by ne square tau, right? So ಇದನ್ನ ನಾವು already derive ಮಾಡ್ಕೊಂಡಿರೋದು, where m is the mass of electron and n is the number of electrons in the conductor, where E is the charge of electron, next and tau is the mean free time or collision between the electron and to that of the atom, right? We can write mean collision time between electron and atom, right? So by using this relation we are going to discuss in case of conductors, right? So what happens in conductor if we increase the temperature, right? So if we consider this one as one conductor, right? So here we are going to increase the temperature, right? So in conductors n is independent of the temperature. So now yesterday temperature is ಮಾಡಿದ್ರು, the number of electrons, that means free electrons which are present in the conductor will not vary. So already if this conductor has some electrons, that is free electrons which are moving inside the conductor, right? So as we increases the temperature, there are further we are not getting any more extra electrons within the conductor. That means the first point is n is independent of temperature. This is only in the case of conductor, right? So now temperature increase ಮಾಡಿದ್ರೆ ನಮಗೆ ಯಾವುದೇ ತರದ extra electrons inside the conductor present ಇರೋದಿಲ್ಲ. So initially ಎಷ್ಟು free electrons move ಆಗ್ತಿರುತ್ತೋ same amount of electrons will moving inside the conductor, right? So next m is constant and E is constant. So mass of the electron constant and the charge of the electron is also the constant. So the resistivity rho is inversely proportional with, we can write this one as 1 divided by tau, right? So when tau is what? The mean collision time between the electron and to that of the atoms, right? So as the temperature increases, the electrons which are present inside the conductor get velocity, right? So electrons free agi move ಆಗ್ತಾ ಇರುತ್ತೆ. As we given the temperature, the electrons which are present in the conductor gains the velocity. If it gains the velocity, that means the velocity is increases. So that velocity we call as, that one is the drift velocity, right? So as the velocity of the electron increases, the collision time between the electron and to that of the atom is reduces. So its speed of ಹೋಗ್ತಾ ಇದೆ ಅಂದ್ರೆ initially it takes some 10 seconds to collide with the atom, but as the velocity increases it will take some 5 seconds. That means the mean collision time between the electron and to that of the atom is reduced, right? Why? Because we increases the temperature. So temperature increase agtidage it gains the energy, that is the thermal energy. So energy gain agtide andre electron enagtide it moves with a faster velocity. So velocity increase agtidange collision between the atom and the electron enagutte namage decrease agutte. That means the tau value decreases as the resistivity is inversely proportional to tau. So if tau value decrease agtide andre resistivity increases, right? So this is what happens in case of the conductor. So as temperature increases the mean collision between the electron and to that of the atom is decreasing. So due to this the resistivity of the conductor increases when the temperature increases, right? So if you plot the curve for resistivity and to that of the temperature we get this one. So this is for metals. So this year in supplementary, so they asked this question for 1 marks. So in the same time this year in NEET exam also they asked the same question. This one, write the relation for the resistivity and to the temperature in copper or in any metal we get the same curve, right? So ನೀಟ್ ಅಲ್ಲಿ ಕೂಡ ಕೇಳಿದ್ದಾರೆ ಇದೇ ಇಯರ್ ಅಲ್ಲಿ ನೀಟ್ ಅಲ್ಲೂ ಕೇಳಿದ್ದಾರೆ ಜೊತೆಗೆ ಸಪ್ಲಿಮೆಂಟರಿ. ಸೊ ನೀಟ್ ಅಲ್ಲಿ 4 ಮಾರ್ಕ್ಸ್, ಸಪ್ಲಿಮೆಂಟರಿ ಅಲ್ಲಿ 1 ಮಾರ್ಕ್. ಸೊ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ several times ರಿಪೀಟ್ ಆಗಿದೆ. ಸೊ why we are in starting, we are not start with the origin means initially it has some resistivity, right? So that's why we are drawn from some values, right? So idu namge conductor. So this one is the graph, very important, right? So next, so the second one is for insulator and semiconductor, right? So what happens when we increase the temperature semiconductor, right? Insulator or semiconductor. So again by the same relation, so here m is constant, e is constant, so tau and n varies, right? So from this we can write rho is equals to m divided by n tau, or we can relate this one as proportional to m divided by n into tau. So insulator means, so conductor alli enagtittu namage free electrons which are moving inside the conductor, but insulator alli there are no free electrons to move inside the conductor, right? So that is the difference between conductor and insulator. So insulators alli namage electrons free agi move agta iralla. As we increase the temperature to the insulator, the atoms which are bonding the free electrons or valence electrons, the outer shell gets free, right? So aವಾಗ ಏನಾಗುತ್ತೆ ನಮಗೆ free electrons ಸಿಗುತ್ತೆ. That means the n value is increasing, right? So as we increase the temperature, the electrons, the number of electrons will increases. So as n increases, the resistivity automatically decreases, right? So this is in case of the insulators or in semiconductor. So ಇಲ್ಲಿ electrons move ಆಗೋದಿಲ್ಲ inside the semiconductors or sorry inside the insulator. Insulator ಅಲ್ಲಿ ಯಾವುದೇ ತರಹದ electrons move ಆಗೋದಿಲ್ಲ. So there is no matter between the collision between the electron and the atoms. So only it relates with the number of electrons. So as we increase the temperature, the number of electrons will increase. So initially it will come on 5 ಇತ್ತು ಅಂದ್ರೆ as we increases the temperature we get some 20 or 30, right? So this is just an example I am saying. So as the number of electrons increasing, automatically the resistivity in insulator decreases, right? So So if you plot the graph for insulator for semiconductors, so rho to the temperature, we get the curve, right? So this is for semiconductor. So on one more we have, that one is for the alloys. So as already mentioned, alloys are, that is some example for manganese and nickel. So already mentioned says that these are very less sensitive to the temperature, right? So if we plot the graph for resistivity and to the top the temperature, we are getting the linear curve like this, right? So resistivity ಮತ್ತೆ temperature. So now temperature vary ಮಾಡಿದ್ರೆ resistance very less amount ಅಲ್ಲಿ ಏನಾಗ್ತಿದೆ ನಮಗೆ vary ಆಗ್ತಿದೆ. So these are very larger amount, right? So increase ಆಗ್ಬೋದು ಅಥವಾ decrease ಆಗ್ಬೋದು. But in case of alloys ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ these resistivity are very less sensitive to that of the temperature. So hence we are getting the linear curve. So ಇಲ್ಲಿ ಕೂಡ ನಮಗೆ 0 ಇಂದ ಏನು ಸ್ಟಾರ್ಟ್ ಆಗ್ತಿಲ್ಲ ಅಂದ್ರೆ initially it has some resistivity in the alloys, right? So hence we get the curve some values. So it has initially some resistivity. So ಈ curve ಏನು indicate ಮಾಡ್ತಿದೆ ಅಂದ್ರೆ the alloys which has initially at some values, that means 0 degree Celsius tondre in 0 degree Celsius also we have some value of the resistivity, right? So this is about the temperature dependence of resistivity. So three curves are very important. So one is metals, semiconductors and alloys. So if they mention the manganese or nickel, we need to draw like this. So most of the cases they mention the names, right? So in silicon or germanium, if they mention means the curve is the parabolic shape, that is exponentially decreasing curve, right? So this is about the resistivity. So on the next one is electric energy and electric power, right? So already first year we studied the energy and power. So here we are going to discuss the electric energy and electric power. So what is electric energy? Is the total amount of the work done to maintain the current in a circuit. So that energy we call as the electric energy. The rate at which the electric current is maintained, that is work done in maintaining the electric current, so that one we call as the power, right? So to derive the relation for the electric energy and to that of the electric power, initially consider one conductor having the resistance R, right? So consider a conductor AB, it having the resistance R, and this conductor is connected to the external source, that is battery, applying the potential V, right? So the current is flowing in this direction. So I is the current which is flowing in the circuit, right? So now as the current is flowing from A to B, that means the potential at A is more than potential at B, right? So now potential at A we taken that one as VA and potential at B we taken that one as VB, right? So the convention sign we taken for the current which is flowing from A to B, means the current which is flowing from A to B, nothing but the current is drawn from higher potential to the lower potential, right? So the change in potential between A and B, because that one has B, that is equals to VA minus VB, right? So calling this one as a first equation. So where V is the potential which is applied across the conductor, where A is the potential having the higher potential and B which having the lower potential. So the net potential difference we taken VA minus VB, right? So current is flowing means the charges are flowing inside the conductor. That means the electrons are flowing in the conductor, right? So the small amount of charge flowing for the time, that is small time delta t. So we can relate current I, that is equals to delta q by delta t. So current flow ಆಗ್ತಿದೆ ಅಂದ್ರೆ ನಮ್ಮಲ್ಲಿ charges flow ಆಗ್ತಿದೆ. So small charges flow ಆಗ್ತಿರೋದ್ರಿಂದ ತಗೊಂತಿರೋ time ಎಷ್ಟಿದೆ? Small time. So that's why delta q by delta t, right? So from this we can write delta q is equals to I into delta t, right? Now we are going to discuss about the energy. So first the potential energy at point A, right? So next the potential energy at point B, right? Potential energy at A, that is from the equation, that is V is equals to Q into V, right? So potential energy U, that is equals to Q into V. So here the charges which are flowing is small amount, right? So the potential energy at A we taken as UA, that is equals to small amount of the charge QA, sorry, delta Q into VA. So this derivation we already did in our last chapter, right? So potential energy we can write that one as charge into potential. So similarly potential energy at B, that is UB, that is equals to, so here delta Q into VB, right? So now change in potential energy. So change in potential energy we can write that one as delta U is equals to UB minus UA, right? So we have UB and UA, that is delta Q VB minus delta Q VA. So from this we can take delta Q as common, we get VB minus VA, right? So now substitute the value here, VA minus VB. So if we rearrange this one, we get minus delta Q into VA minus VB, right? So in place of VA minus VB, we can write that one as V, right? So delta U is equals to minus delta Q into V, right? Change in potential energy delta U equals to small amount of charges into the potential difference applied between the conductor, right? So again delta Q we have the relation I delta T, this one we write IV into delta T, right? So this is from equation 2, right? So delta U ಅಂದ್ರೆ ಏನು? Change in potential energy. So charges which are flowing from A to B. So A ಇಂದ B ವರೆಗೂ charges flow ಆಗ್ತಿದೆ ಅಂದ್ರೆ potential energy ಏನಾಗ್ತಿದೆ ನಮಗೆ? We get the magnitude IV into delta T. I is the current flowing in the conductor, V is the potential which is applied across the conductor, and delta T is the time. So in this time the charges which are flowing from A to B. So negative symbol represents what? So the negative symbol represents the decrease in potential energy. So A ಇಂದ B ಗೆ ಹೋಗ್ತಿದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ charges ಏನಾಗ್ತಿದೆ ನಮಗೆ? It loses its potential energy. So minus represents what? There is a decrease in potential energy. That means which is less than 0, right? So potential energy decrease ಆಗ್ತಿದೆ ಅಂದ್ರೆ from the conservation of the charges, right? So the total energy is equals to potential energy plus kinetic energy, right? So there is a conservation of charge, means sum of the potential energy and kinetic energy is equals to 0. That is delta U plus delta K, that is equals to 0, right? So we know delta U minus IV delta T plus delta K is equals to 0, delta K is equals to IV delta T, which is greater than 0. That means positive value. So positive value represents what? The decreasing potential energy is converted to kinetic energy, right? So potential energy decrease ಆಗ್ತಿದೆ. As potential energy decreases, automatically the kinetic energy increases. As the kinetic energy increases, so if you consider this one as the conductor, these are the atoms. So these are fixed atoms in metals, or we call that one as ions, right? So charges flow ಆಗ್ತಿದೆ ಅಂದ್ರೆ nothing but the electrons are moving. So these electrons gain the kinetic energy, right? So potential energy, decrease in potential energy andre gaining the kinetic energy. So gaining kinetic energy means the electron gains the kinetic energy. So these electrons bombard with the atoms. So these are fixed atoms, right? So as these electrons will bombard with the atoms, so these atoms gains the energy from the electrons, right? So idu fast moving electrons, it has a kinetic energy. It imparts its energy to the fixed atoms, right? So as these atoms gains the energy, as the atoms will not move from one place to another, so these will vibrate at its initial position. So ಆ positions ಅಲ್ಲಿ ಏನಾಗ್ತಿದೆ ನಮಗೆ atoms vibrate vigorously. That means fastly the atoms are vibrating, right? So as these atoms are vibrating, so here the conductor gets heated, right? So ಏನಕ್ಕೆ ನಮಗೆ conductors heat ಆಗುತ್ತೆ ಅಂದ್ರೆ as the charges flow from one point to another, it loses its potential energy and electrons gains the kinetic energy, and these energy bombard with the atoms. These atoms will vibrate. So as these atoms are vibrating, so by that the conductor gets heated, right? So aduna navenna karitivi power. So now power, it is the energy dissipated. So that means there is a loss, right? So heat ಆಗ್ತಿದೆ ಅಂದ್ರೆ there is a loss of energy, right? Energy loss or energy dissipated, right? So that we return that one as the work done. That is W, delta W is equals to IV into delta P. So this one is the electrical energy which are providing to that of the conductor. So iduna navenanta karitivi energy, current flowing in a conductor with respect to the time. So now ಎಷ್ಟು time na current flow ಮಾಡ್ತಾ ಇದೀವೋ in the potential difference, so ಅಲ್ಲಿ ನಮಗೆ energy loss ಆಗುತ್ತೆ. So that energy we call that one as the electrical energy, right? So this delta W we can take that one as the energy, right? So that is the work done, right? So now we have power dissipated or power loss. So from the definition we know power is equals to work done in maintaining the current which is flowing in the circuit. That is rate of work done. Rate of work done means delta W divided by delta T. Rate means with respect to time, right? So we know delta W, that is IV delta T divided by delta T. So delta T get cancelled. Power is equals to I into V. So this gives what? The final expression, right? So from Ohm's law, V is equals to IR, right? So now where V is the potential applied across the conductor and R is the resistance of the conductor, right? So if we replace V with IR, we get the other forms of power, that is I square R. When V is substituted with the IR, right? So if we substitute I with V by R, we get P is equals to V square divided by R. So these are the other forms of the power dissipate or power loss, right? So this is in terms of current and resistance. So this one is in terms of voltage and resistance, and this is in terms of current and voltage, right? So energy is IV delta T, and the power dissipate or power loss we taken as work done per unit time, right? So work done in maintaining the electric current in the circuit for the time delta T, right? So here this energy we can also write this one as IV into T, where T is the time, right? So next class we will continue. Thank you. So any doubts?